Hey everyone, thanks for joining. My name's Anna, I'll be your producer. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to review our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters and moderators to answer. Our session is being recorded. It will be available to view on demand right here on the Reactor channel. With that, I'd love to turn it over to our speakers for today. Bruno and Don, thanks so much for joining.
Hello, everyone. Hello, everyone. Hey, welcome to another session of Microsoft Reactor. My name is Bruno Capuano. I work in GitHub/Microsoft. I'm super happy to be here to share some lesson learned about agents and more. I'm also happy because I'm here with Don. Hey, Don, how are you?
I'm doing well this morning. Thank you, Bruno. I work for NVIDIA, and I work in the marketing department there, working with the product managers, and I'm looking forward to doing another webinar with you. And yeah.
Yes, we did once about agents and voice and more. I think it was last month or 2 months ago. I don't know. It was a fun one. I learned a lot about models, about the parakeet models and the other models that there are in NVIDIA, where you can do a lot of voice activities, text-to-speech, speech-to-text, and more. But today we are going to talk about something different. Today is a more enterprise version, because we are going to talk about agents. And everybody's talking about agents these days. Everybody said and realized that the models are important, but the harness, everything that you do around the model is what really, really add value. And we are going to show a couple of experiences, hardware resources, and lesson learned and more that we have to really, really make this work. So this is the agenda. This is what we are planning to do. By the way, I didn't tell about this, but I'm joining from Canada. So happy to be here. I see a couple of people joining from India here. We also have Nick and more. Let us know where are you joining. But as I said, today's talk is about what we learn, how we can take the best of Azure, Foundry, NVIDIA, and more to really, really deploy robust agents. So with that said, if anybody has a question, I am reading the chat. Don and myself are happy to try to help at any time. But let's go back a little. Let's do a quick recap about what is an agent. So let's start at 3-4 years ago. Everybody probably remember the ChatGPT era. Oh my God, we have a chat that is really, really good. It really feels like we are talking with a person and more. We start to learn about the GPT models and more. And in the next years, we realize that these LLMs are very good. And when we figured out how to connect them to external services, we said, okay, hey, oh my God, my agent, my LLM can see my calendar, so they can give me insights about my calendar, my emails, and more. With all of this, we get to a point that we start to talk about agents. And an agent is basically an LLM. Choose your own flavor here. Today, we're going to use the Neotron family because they are amazing, and I really like it, locally and in the cloud, both. And then we provide a set of instructions that we are going to define basically the behavior of the agent, and we connect the agent with tools. And this is the ABC. And the tools can be, like an example, a vector database, so the agent have memory, an external service for weather, an external SaaS application, and more. With this, we have the concept, we have the bare concept of an agent, and the agent activities are triggered by an input from a user, by another agent, by a scheduler alerts, and more. And the output is probably going to be a response to the user, call to another agent, or other stuff. So this is an agent. And again, there are better sessions that explain what is an agent much better than myself. But with this in mind, what we learn is that, hey, everybody builds an agent. If you have any developer subscription, if you have any LLM subscription, any AI subscription, you probably build an agent. And that's amazing. You can build an agent in 5 seconds, and you can prototype something, and it's great. However, when you move to enterprise scenarios, to more production scenarios, you start to figure out a couple of things that we are going to see later. Like an example, it's very important to take advantage of the resources that you have. You can't use an agent unless it's a very simple agent. You can't use an agent in a simple call. Usually what you do is you start to add some steps inside the agent. You need to persist this state, so you need to have some kind of durable agent framework there. So there are a couple of things that you need to do here. In example, another one is that, hey, we learned that you need to be able to create an agent, a harness for your LLMs, where you can switch models, because we have model 1, and then in 2 months we have model 2 and 3 and 4, and you need to be able to scale or to upgrade to the new model without breaking your agent. So there are a lot of things that we've been doing here. I am not going to even start to talk about hallucinations and more. And by the way, I see more people here, Seattle, Angola, India. So hey, welcome everyone. But the cool part about this is we did all of this lesson learned at Microsoft. We pick up all of the frameworks that we have to do agent. By the way, we have a couple of them, and we created Microsoft Agent Framework. Microsoft Agent Framework is GA right now, so it has support. It was released GA, I think it was in April last month, or probably in March, a couple of months ago. But the idea is that it's an open source framework that allows us to create agents. And on top of that, what we are doing is we are basically embedding and using all of the standards that we have in the industry. Like an example, if you want to use MCP tools, Microsoft Agent Framework support the latest MCP SDKs and more. If you want to make agents talk to each other, agent to agent, you can use Microsoft Agent Framework for this. Little spoiler here, we are going to create a NeMo agent that is going to be talk with Microsoft Agent Framework agent later as one of the demos. But the idea here is that we have a framework to do this. We have a framework, by the way, it's driven by the community, it's open source, it's great. You can take a look in the URL there, and it's ready for production. Because we also know that there are so many ways to create agents. And I am not going to, this slide is to speak 10 minutes about this, but there are so many ways that you can create agents that we need to have something else. Where we are going to host our agent when you create your agent locally and you want to scale and more. What is happening here? How you do that? And this is the moment that we came to Foundry. Foundry is our platform to everything AI related in Azure. And again, we learn about this. We apply everything that we've been doing in Azure for the last 10, 15 plus years, scalability, observability, and more into the Foundry services that we have here. We have models, agents, and everything else. But the cool part here is that we also have a specific service that is the agent service that is focused on support agents and support multi-agent frameworks, connections to local agents, hosted agents. You can host your own agent, like an example, a NeMo agent. You can do a lot of stuff. And if you probably know me, you know that, hey, I have this TTD script metric in my head, which is time to demo. I like to do demos. So here, I'm going to stop a little. I'm going to show you a couple of Foundry and Microsoft Agent Framework demos right now. That said, one important thing is that I recorded my demos because I don't have my voice in a very good place today. So let me play the video and let me know if you can hear it later. And this is a Microsoft Agent Framework sample application. This is kind of the hello world that we can use. In this scenario, we're going to create an agent locally using Ollama and LLM Studio, using one of the Neotron's model. And as you see here, this is a C#. We have Python also here. But the idea is to use the libraries that we have here, get some endpoints and models. And once we have this, there are different endpoints for locally for Ollama and also for LLM Studio. We are going to create a chat client, and with the chat client, we're going to create an agent. And the agent is going to be a very simple agent, no tools, no skills, just an agent to do chat. And it's going to basically, the name is going to be Neotron agent, and it's going to basically ask, get the question and answer the question. That's it, it's very simple. So if we take a look here, we have Ollama running. Here is running. Let's open the monitor to have it here, and let's run this application. So let's do app.cs with the model local. When we do local, it's going to go by default to Ollama. So it's going to lower here. We see that the model that is loaded right now is Llama 3.2. But when we ask a question, because we're using the Neotron model, we are going to see that the Llama model is going to be unloaded by Ollama, and it's going to load the Neotron model. So after a couple of seconds, there it is, unloaded the Llama, and it's going to load the Neotron. And once the model is loaded, it's going to answer the question. And of course, the first time takes some time because the model is in memory. If we do this again and do something, please solve 2 + 2, it's going to be faster as the model is already in memory. Ollama is great to do these kind of things, but I also like to use LM Studio because LM Studio gives us kind of a console application. And in LM Studio, I have loaded the Neotron 3 Nano Omni, which is also supports vision. It supports a lot of other features. And I really, really like to see how this one is working. And by the way, if we take a look at the GPU, in this specific machine, I'm working in a dev box machine. I have an NVIDIA Tesla T4 working here, which is a very, very nice developer GPU to use and work. And now we can see here the model is already there, loaded by Ollama. So let's do this. Let's close Ollama and let's switch a little to LM Studio. We have LM Studio. We have the other model here. This is Neotron 3 Nano Omni. Yes, Ollama is offline. And what we have here is the console log for this. So when we run this, but instead of doing local, we do local LM Studio, and we run this question, we are going to start to see, like an example, let's do a hi again. We are going to start to see a lot of important information about how the model is being loaded, a couple of logs. We have here, which is the model, where it was created. We can define here the input and output. As part of the LM Studio configuration, we can start to say, hey, this is the model, this is how it's going to do, the CPU that's going to use, how many concurrent predictions can be run, how many the GPU offload here, how big is going to be the model support in tokens for the context length. Right now it's 4096, kind of the default, but we have all of this info here. And again, this is a very simple way to use Neotron models locally. Ollama, LM Studio, or any other provider like Foundry local if we want, and literally 10 lines of code to get here. So that was a very high-level overview of how you can use Microsoft Agent Framework. And the second part here to show is going to do very quickly is Foundry. This is the portal where you create a project. You are in Foundry. And of course, in Foundry, you have the chance, let me zoom this a little, to create agents. And each agent is going to, there are two types of agents, the prompt agent and the hosted agent. Put a pin on the hosted agent because this is what we are going to see later running. And of course, you have the chance to deploy any type of models. And if I want to deploy a model and I search an example for NVIDIA, let's search for all models. For NVIDIA, we can start to see here the whole set of deployment for models that we have. I think I ran out of, if I want, I should pick up one of the NVIDIA Neotron 3. This is the Neotron 3 Nano, and I want to deploy it. I think I ran out of my quota. I need to talk with my manager, and my manager need to talk with Don about giving me more quota because I was testing so much, I was doing so much that if I want to pick up one of the projects, oh no, I need to create a project, and then let me see if I still have a quota. Oh no, I don't have a quota. I already used my quota for the demos, but this is as easy as deploying this.
The token count explodes when you do agents because they're reasoning and thinking, and they keep going through the model, wham, 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 and double checking themselves, and wham, 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 and the token count.
I know. And a little spoiler here. We are preparing a lot of amazing announcements and news for Build in a couple of weeks. And I think I also use all of my quotas doing all of these announcements, log into Build is into which register for the online sessions. June 2 and 3 is there, and you're going to see a lot of things. But hey, this is how easy you can deploy a model, and the model is going to be in the cloud. And as easy as I use it locally, you can also use it here in the cloud. Just change the endpoint. Of course, there are some security and more stuff that we are going to talk later, but this is how you can start to use these models on Foundry. But it's not just about models. Let me go back to the slides, and I am going to ask John a little to explain, because Neotron is not just model. There are a lot of stuff here, Don, yes?
Right, yeah. So Neotron provides you with, Neotron is really an umbrella. It's a lot more than models. So it provides you with industry-leading open models, as well as open data sets, libraries, and blueprints for agentic AI. And there are massive open data sets that you can use in training your models, and I'm going to talk about those more in a minute. Some of the industry-leading models would include Neotron 3 models for reasoning, the Neotron vision language models, the Neotron speech models that Bruno was talking about earlier, the Neotron retrieval models, if you're doing RAG, very, very common pattern. common blueprint. And then the Neotron safety models, just as some examples. Useful libraries include the NeMo data preparation tools, because you got to prepare that data. I'm going to talk more about that. The Megatron core training framework, Neotron, NeMo RL and GEM is used for training your agents, as well as NeMo Evaluator for evaluating and benchmarking the different models and agents, so you can make your choices along the way. And then the NeMo Agent Toolkit that helps you build the agents. So scripts include the Neotron cookbook and the Neotron recipes that have common workflows. And lastly, we give you some blueprints. One, for instance, is for agentic research. Another one is for video search and summarization. And a RAG, there's one for RAG application and more. So the blueprints are there. Give me the next slide. Great. And so NVIDIA models are directly available, as Bruno was saying, through the Microsoft Foundry model catalog. Now that includes Neotron models for chat, for reasoning, for retrieval, parsing, safety, vision, speech, all kinds of models. So if your team is already building in Microsoft Foundry, you don't have to go somewhere else to start. It's all the NVIDIA AI technologies are right there. Next slide. And here are some more models from the Microsoft Foundry model catalog, and more being added every week. Next slide. So about those data sets. These are open data sets, and these are a gold mine for you. They are massive in size and very, very comprehensive, and nobody knows they're there. They're more and more people are figuring it out and picking them up and using them. If you're making a foundation model, then you're interested in things like the data set for Neotron pre-training. It's got data in there for coding, for STEM, for safety, for chat, for multilingual, right? So you can teach your neural network all those things. There's Neotron Climb Lab for optimized pre-training mix. We also have, when it comes to alignment, we have the Neotron post-training, again, for code and STEM and chat and reasoning. We've got Help Steer. That is a great data set to feed to your agent to make sure that it's going to be helpful and factual and coherent. Neotron VLM2 for OCR is industry leading. And if you're developing for agentic AI, we've got something like the Neotron Mind, which is structured mathematical dialogues that you can use. For safety, we've got the Content Safety 2 for kind of like the human to LLM interaction. We've got the AIQ agentic safety for contextual risks, right, in the context. Are there any problems in there that can be creeping in? We've got Content Safety 4 for multilingual training, and Content Safety Audio for multimodal safety. And then lastly, for sovereign AI, things like Neotron Personas for grounded national demographics, or Neotron PII for sensitive data mitigation, and we're letting that PII out, or Granary, which is for open multilingual speech corpus. You know the slide? And here's an example of a blueprint. Now, these blueprints are NVIDIA's reference architectures for making common AI applications. And this is just one example. This is the RAG example. So bring your eye to the bottom. You see that the multimodal documents are being ingested. Notice all the models that, this is what Bruno was saying. There's an orchestrator and there's a ton of models. It's not like one model and it gives the answers back. No. There's an orchestrator and there's all this stuff that needs to happen, which is why CPU use is going up fast in addition to GPU use. But let me get to it here. At the bottom is multimodal documents are coming in. The blueprint breaks those documents into page elements, graphics, they're all recognized, right? Tables and text using Neotron parsing. So then all of that goes into the extracted elements. Of course, then you have to, get the embeddings for those extracted elements. And then the embeddings are stored in the vector database, which is shown as NVIDIA cuVS here, but it's whatever vector database you like. This is just a blueprint. You can substitute anything in that you want, extend however you want, right? It's just to get you started. Now, when a user asks a question, the query is checked for safety. Then you need to turn it, using embedding model, you need to get the embedding. And then you can do a match in the vector database and say, hey, for this vector, give me the top n vectors that are close to it, right? And that's going to yield you some data chunks that you can then re-rank for relevance, and then take the best of that and pass it through Neotron models, which are going to generate that grounded response. A safety model, of course, at the end is always a good idea on the way out. So there's your blueprint. And next slide. And this is my last slide. So this slide shows an end-to-end workflow for building and improving enterprise AI agents with the NVIDIA technology. So it starts with the use case. Before choosing any models or tools, you need to define the business task, the users, the required data, and the success criteria. Next, you have to prepare and generate that data. Well, we've got NeMo Curator for you. We've got NeMo Data Designer to help you clean that data and create the data that you need to tune, to train, and to evaluate. You need data for all of that. So we've got you covered. All open source. Then you select the right model using NeMo Evaluator. You can compare models for speed and quality. You might want to see how many tokens a model is chewing to get something done. That's an important metric now, and we try to minimize that because you want to keep the costs down on these AI applications so that more people can run them and afford to use them. So to help you build the agent, there's the NeMo Agent Toolkit, and you can connect it to enterprise data using NeMo Retriever. We've got guardrails for safety. I talked about some of those earlier. And from here, the agent can be deployed. The easiest way to deploy an agent is with NIM, because it's a Docker container that comes with everything that you need to keep that model running, and you get enterprise class support with that. And once it's up and running, don't forget about your data. Don't keep making the same mistake, agent. Learn. I'm getting aggravated here. So, you need to create a data flywheel so that the agent can monitor what's going on and improve its performance, while it's being used. As Bruno will probably show you some of these things. Here we go.
Yes, because, hey, by the way, there are a couple of very interesting questions in the chat that I'm going to go back later and we are going to answer those. But yes, this is amazing. And I said this the first time that I started to work with Don last month or 2 months ago, that I didn't know that NeMo is this family of everything. So for me, it was just the Neotron models, but there are a lot of other stuff. We are going to see a couple of these implemented, but for us in Foundry, the key pieces, there are a couple of pieces that we are using. One of the key pieces that we have here is that how we run this, how we take advantage of all of this when you really want to use it in the cloud. So one of the key services that we have is GPU's container apps. And by the way, another pin there, be aware of what we are going to announce on Build, because there are huge announcements on this. And everybody's crazy about getting GPU support and more. So this is going to be a super, super set of amazing announcements on this. Then we have the chance, and by the way, we're going to see one this up and running. When we have the chance to host, oh my God, this is not well aligned. I just realized that you can probably see that we've been working on the slide literally until right now, and I need to fix this and center the title. But we also have the chance to run those models, the Foundry models, on serverless GPUs, which is kind of the same concept. You can pick up any of the models that you want, one of the NVIDIA models that are provided by NVIDIA, or the other NVIDIA models that you have, in example, in Hugging Face, because we have a lot of Hugging Face models, and you can run it also there. and they automatically scale. They are doing real-time inference, everything that you want and specs here and available there. And this is what I also want to share today. I want to show, because this is the moment where we start to have more advanced scenarios. If we keep on this line, we see that we have NVIDIA running in container apps with NIMs, or you have Apache Spark. I'm not an expert on the Spark, but people who love this, oh my God, we have a lot of GPU workloads and more. But once again, let me show you how this looks in real life. So let me stop the slides here, and let's go here a little to the container apps. So what I have here a container apps environment. This is Azure. This is one. Let me zoom this a little. So this is a container apps environment, and I have here in a resource group, I have deployed a couple of things. I have a Azure Machine Learning workspace, because I am taking advantage of these GPUs to also do kind of fine-tuning and train a couple of models. And I have here a container apps environment where I also have a couple of container apps. In this environment, what I have here is in my workload profiles, I have one profile that is called GPU something, GPU profile. And I know it's the worst name ever. I'm not very good deploying and doing these things, but this all came here from the deployment scripts that we have here when we have a bicep file, by the way, to deploy. Oh my God, this is a spoiler. This is a Neotron agent that you're seeing here. Let's close this and open this later. So here, when I deploy and I create my container apps, and let me zoom this a little so everybody can read this, one of the environments that I'm creating, this container apps environment, it has a GPU profile name for the profile that we're going to use, that is going to use these T-Force NVIDIA's GPUs, the same GPUs that I was using in my developer deadbox that used before. I like that one because I think it's 16 gigabytes virtual RAM. Or I can't remember the specifics, but it's very, very good to develop and to work in production also. So at this moment in Azure, in that container app that we've seen here, if I want to run something, if I want to see which are the applications that there are here, I will say that they can use this GPU. And if we want to see this, what I have here in my Neotron dev container app, I can go to let me go here to the console, and let's create a console. Let's connect, maximize a little. Oh my God, the console looks very weird. Let me minimize and maximize again. There it is. And I think it's NVIDIA and SMI. And here we can see the details of what is running inside these container apps. And as you can see here, we have the Tesla T4 GPU. So everything that is running here, it's running using that GPU. And the code for this one, I am going to say sorry in advance. It's a very simple Docker file that basically have a chat and expose a chat with using one of the Neotron model. Literally what I did locally, but on the cloud. Instead of running the model locally, I am running in the cloud. So let me show you a demo of this. I also have recorded this one. So let me go back here. And in this scenario, what we are going to do is we are going to run the same C# application, but we are going to run this application using a remote container apps that is using a GPU and is having the model loaded there. So instead of running the model locally, we are going to run this on the cloud. And we have here the application is going to use, as I said, the remote endpoint. We have NVIDIA Neotron Mini 4B Instruct as the model there. Let's ask a question. And we have the connected resource there. On the right, we're going to see how in the Azure resource, we started to see that the model is loading and responding and more. If we run the application again, and we ask another question like, please solve 2 + 2, we are going to keep seeing the model working with more logs and more. An interesting part about this, as this model is running literally using a GPU. If I go here, let's maximize. So I think I can probably run these videos and people won't even know that I am running the videos. They are here and more, but using the chat application, this type running using the NVIDIA model, the container app using the GPU with the model on the cloud. But this is the moment that as a developer, I need to do kind of a mea culpa, and I start to say, okay, this is great. I just hosted the Neotron model I have locally using Foundry Local, LM Studio, or Llama, and I hosted in the cloud. And that's good, yes. That's good enough Probably no. Why? Because usually when we do that, we don't implement the best practices, or we forgot about topics like security. And by the way, Azure give you a lot of good practices of security by default, but we probably need to do more. We don't implement, when we host a model, stuff like observability, traceability, scalability, and more. That's the moment where we can go and start to use the NeMo templates to deploy a model. And this is a great one, because instead of deploying just a Neotron model, we can go to the NeMo catalog and we can start to see, hey, this is the one that I want to have. And the NeMo templates are the one that are enterprise ready, because they have all of that. And also, Don was telling me that they even have versioning, so you know where you are. You know, if you have a new branch with a new version, you decide if you want to upgrade or not. These are all containers, and they are great. If you want to, we have a question here. Let me show something that Kumar was asking, hey, where we can find those datasets? When Don was talking about getting the models, getting the datasets, and more, I think, let me bring my browser here. When you're talking about models, you can go directly. My personal path is going directly from Azure, because I have the model card there, and 2 clicks later I arrive here. But I'm sure that for the model is probably the same. But if you want to take a look at the models, this is the place to go. So if you go to buildnvidia.com, this is where you are going to access everything. And by the way, it's super important that you also create an account and you have your API key, because in order to use a lot of resources that are here, you are going to need to be validated with your API key. It's free. You don't need to do anything. That's correct, Don. Yes, I'm using my API key with my personal account, and it works like a charm. I did give it a try for this, but this is the place where you're going to find the models, the blueprints, and somewhere here are probably the data sets. Somewhere here, and of course, it's a catalog of stuff, so you can take a look. Okay, I want to see developer examples about, I don't know, let's find something about an AI agent. And I think there is one here for this. Yes, the PDF to podcast, where automatically is going to use a couple of text-to-speech models to read the PDF, create kind of a conversation, and use it there. So it's kind of nice. It's ready to go. You can give it a try. Most of these are also available, so you can take a look at the code in GitHub. So you have everything that you need here. And hey, ready to use. So going back to the question about where to find the data sets, this is the place, again, build.nvidia.com. And this is where I found the stuff. I don't know, Don, if I am missing another URL endpoint or something. I don't know if you have developer.nvidia.com or something like this, or this is the one that we use.
That's a great place to start, yeah. You might end up in the NCG catalog at some point, but
yes, I know, a couple of clicks later, but it's part of our developer process. We learn how to do this. So for models and blueprints and datasets and more, this is where we'll probably start to see what we have.
Yeah.
Going back here, as I said, hey, this is fine, but this is just a container app hosting a model and more. If I want to do this really, really well, you've probably seen here that the name is, spoiler here, this is the same. This is another container app using a GPU, but instead of using the code that I did it by myself, hosting the model and more, this is using one of the NeMo templates. The one for I can't remember, I think this is one of the Neotron models also. So everything is here, and it's prepared, it's ready to rock in production, because it's ready to have these scenarios running, in example, using the GPU with observability, traceability, and more. This is very similar. I will probably do this, or as we've seen before, I will probably deploy a model directly here. This is probably the best way, because somewhere here you also have the license, the model ID, the card. You can go to Hugging Face and see more. So there are kind of 2 options that you can do this, but this is the good part, on the sense that, hey, yes, you can really do this. You can really start to take advantage using NeMo models and more. And someone asked me when we were talking about this, yes, but what you can do there? Give me a kind of a real example of what you can do there. So this is old. I think this is kind of an old, but this is the Hello World. When I say old, this is last year. No, February this year. Sorry, this is how fast we move this in these days. So this is my friend Nitesh, who creates a sample that basically put all of the pieces together. But when you are doing AI with local models, GPUs on the cloud and more, this is kind of the hello world, which is, let's use a image generation model, stable diffusion model, very popular. There are tons of them, but let's use this on the cloud and the GPU, NVIDIA GPU in Azure. Perfect, to generate images, amazing. But let's also do this using Azure functions, because Azure functions are another service that we have in Azure that they can take advantage of the GPU. So here, what we have is basically we create an endpoint, an Azure function endpoint that is going to generate an image. It's going to say, hey, let's create an image, a friendly robot chef cooking pasta and more. We are going to share all of the links later. And everything that you need to do is here, and everything is the repo and how you are going to deploy this and more. But let me show you a running sample of this because I have it here. Let me double check that this is the correct one. So let me run the demo for this. And this is an Azure function that is taking advantage of the GPU's capability that we have in Azure. And in this scenario, this Azure function is going to do something which is kind of the hello world that we have when we create, when we start to use models, that we can enroll models. It's going to generate an image. In order to do this, we are going to use a stable diffusion model. We get one from Hugging Face, and we're going to use the stable diffusion pipeline libraries to do this. It's very easy. Load the model, check for if we have a GPU available. If we have a GPU, we're going to use CUDA. And then somewhere here, we have a post method to do the generation. And we have here the generate, and basically we have all of the parameters that we are going to receive for this. So we need the text of the prompt, and then we have a negative prompt if we want, and then the number of steps, and also the scale. With all of this, it's going to generate the image. This is all standard CUDA inference and pipeline. And at the end, it's going to return a JSON with the success true, and then the image in a string. I know there are better ways to do this. This is just a sample, just a demo, but this kind of works. And we also have a health endpoint here that we can use to, and it's going to say, okay, this is the devices that we have running right now. So if we want to take a look at the health endpoints, I have it somewhere here, and we refresh this. Let's do a pretty print. We are going to see that, yes, again, this model is healthy. It's using the Tesla T4 one, as you've probably seen. I'm a big fan. I'm using T4 everywhere. And the model is loaded. Because the model is loaded, I can quickly go here. Let's minimize this. Let's also close the function. And if I generate a new image, all of the images are going to do is going to be here in this demo output folder. It's empty right now. So let me copy here a small prompt to generate some Canadian images, which is going to say, okay, generate a pixelated image of a raccoon in Canada with 50 steps. Of course, it's going to take some time. The model is loaded, so it's going to be faster. But after a couple of seconds, we should have the image. And by the way, this PowerShell script is also going to open the image here. So we have it here, kind of nice. Hey, let's do something else. Let's do an image of a moose in Canada. Let's see how it works. Let's run this one. Again, it's going to take some time. Step 1, 2, 3, 4. Step 3 is going to decode and open the image locally. And after these 2 runs, we should see, there it is. Okay, kind of a nice moose. And both images are here in the demo output folder. We have here the raccoon, and we have here the moose. The function is loaded here. If we go here and do the same, this is the function. If I go to the console, I open a new console with Bean, and I do, let's maximize this, and I do the NVIDIA SMI. I will see that the NVIDIA is running here. And if I open the logs, I will be able to see also how this is running all the time. And this is one, as I said, hello world example of using a local model to generate images with GPUs on Azure functions. I was mute. Sorry about that. Now you probably start to see why I ran out of my quota, because each one of the demos I'm using a lot of Tesla T4s and other stuff here and there. But taking advantage of GPU is amazing. And taking advantage of GPU when you have these scenarios where you can scale on demand, you can grow on demand, you can use whenever you need it, is really something that you can move. It's really something that you need in enterprise scenarios. But at the beginning, we talk about some other scenarios which are, hey, how about when you have not even long running process, but when you have something that is, you have an agent that they need to do several steps. As I said, the initial developer intuition that we have to do this is to start to do a simple HTTP call that's doing everything. But we have support to do this. We have concepts like durable functions, we have Azure durable functions, we have durable workflows also that they are all supported. And when you put all together, everything in the table, where you have NeMo models, you have functions, you have agent framework, you have durable functions, you're starting to get close to a scenario that can really scale and support this. So let me show you, once again, let me show you one of these scenarios up and running with this. And this is the core part of the story. Because in a standard scenario, we have a trigger for an agent, which is a simple HTTP request. But instead of running everything in a single request, in one request, we are going to schedule a durable orchestration instance. We are going to have an orchestrator that is going to execute in a step. First, in this scenario, we are going to construct the prompt. Then we are doing the model inference. Then we are going to do the result packaging. And after each one of the steps, the durable function checks point state. So if the process recycles, you're going to be able to go back and resume for the last completed activity. That's the difference between a cool demo and a production safe behavior. And now we also have NVIDIA here, because fits really here. We are going to use the NeMo instance instead of having our own deployment here and there, because what we have there, we are going to point to the deployed Neotron model that we have there, and hey, this orchestration logic is going to be the same. So let's go back here and start to use. And by the way, what we are going to use is the durable functions that we have in Azure. So let me go back to my virtual machine and let's take a look at this. All of the code is already here, it's available. This is a C# demo where we have a set of functions. This is Azure functions where we have the start NVIDIA flow that's going to start the flow and give us an ID. And then we have the orchestration for the flow. If we want to run this, if we want to take a look, we can see the orchestrator step. This is running locally in a Docker container. And we can see here that there are already some instance there. It's refreshed every 10 seconds. So when we start the new one, it's going to be there. And the idea here is that we can start a new process, and the new process and the new activity is going to do that. So if I start a new activity, we are going to see that the first step is going to create a durable traceable execution ID. This is after a couple of seconds, we are going to have the instruction there on the orchestration. And when we have this, we are going to be able to see the steps. What we see here at the right is there it is. That's the orchestration emulator. And we can enter here and start to see the steps. Each one of the steps is going to be analyzed there. So we are still running, we are still continuing, we are still working there. And at the end, what we are going to do is have the chance to go to each one. If for whatever reason, I stop here, we can open this again and we can continue from here. The idea here is that, hey, we can finish this, let me finish, let's do all of the steps. We have the full amazing response here and the dashboard verification, so we have here. But what we just did is basically did step by step, everything was recorded in the durable function emulator here, and we can get back here and start to see how we work. We can take a look at the payload, the inputs, the output, the status. We can see each one of the steps, when they happen, and more. And the cool part about this is that this platform not only give us these steps, it also give us access, in example, to go to emulators. If I maximize this, we are going to see that we have agents, entities, schedules, working, and more. So we can start to sync on a full platform, on a full scenario that will really, really help to work on enterprise scenarios. So at the end, what we just seen is the takeaway here is very simple. We can narrate and operate the workflow step by step without losing production rigor. Durable orchestrations give us control, observability, and recovery. GPU give us inference, give us speed where it matters most. So we have the best of the two worlds, put it all together here. And another key part, now that we have durable functions and more, is basically how we can add the human in the loop, because that's a super, super important part of what we have here. And the human in the loop is also there as part of what we have in the durable functions. Let me show you, because the human in the loop is also a very short one. So let me show the human in the loop demo, and then I want to do a live demo. So then I want to do the last one is going to be live. And an extension to the previous scenario could be in a scenario where we have when we require a human decision before model inference. We are going to keep the container apps GPU inference at the heavy step, but we are also going to add the human intervention here. So if we go back here, as part of the sample code, we have the human in the loop sample, so you can take a look at the implementation here. It's taking advantage of all of the features that we have in durable functions and Microsoft Agent Framework. And what we can do here is we can raise and we can trigger this. So once again, we are showing at the right the emulator locally for the orchestration, and then we are going to run the human in the loop demo. It's going to start as before, it's going to start one, and we are going to have basically one of the set steps. We are going to have here creating the orchestration, getting the ID. After a couple of seconds, we are going to ask the user to provide, hey, do you want to approve or do you want to reject the goal? The goal is going to be basically the prompt that we're going to see. We are going to ask the model, which is what are the best practices to deploy Azure Function Reliability. We can see in the orchestrator that we have running the model and it's stopped there. It's waiting for us there. It makes sense. This is what we want to do. It's also adding steps where you have a human that is going to be part here. So at this moment, what we're going to do, let's do approve here. And after we approve, we are going to fast forward until the end. So we are going to say, yes, we approve this, we approve that. So if we keep moving forward, we start to see all of the steps here. And let's fast forward at the end. And we have the full definition, the full executions here. And hey, it's literally taken advantage of all of the NVIDIA NeMo power that we have for inference and execution, the cloud and the functions to orchestrate all of this. And in this case, adding also the human approval in the loop. And hey, now that we have all of the pieces together, now that we have everything there, let me show you, because I am going to go very quickly here of if you want to test all of this, where you have models, agents, durable functions, and more, we have a repository. I'm going to share the links in the chat now, which is the Travel Planner. And the Travel Planner is an amazing example of how you can use this. This is a ready-to-use scenario. This is a ready-to-use template that you can deploy in Azure, and you have an itinerary planner, destination knowledge, and there are a lot of moving pieces here that basically shows how you can put it all together. Remember, we've seen models that then become agents that they take advantage of models using NeMo in example, and they have a lot of pieces here. The Travel Planner agents is also, you can take advantage of everything that we've seen today. And by the way, all of the Neotron family have a lot of stuff. We didn't cover everything here, only a couple of them. But in example, you can switch in the Travel Planner the standard models that we are using there. I can't remember which one we use, but use the NVIDIA models. You can everything literally like I did. Deploy a NeMo model, an NVIDIA model, and use it there. And maybe change a couple of those to see what we have, and maybe host an agent that is going to be used there. The Travel Planner agent is great. You can take a look at the repo, and the repo is very well documented, where you have how it's going to use these durable agents, the full architectures that you have here, where you have an intro, the front end is a React application, and then you have a backend with Redis, then you have the durable task scheduler to manage this long-term duration of agents, and you have an orchestrators and more. So everything that we've seen here, you can start to play around, and you have it in the travel agent. And the last piece that I wanted to show is, hey, but we talk about, I don't have time to do a live demo of this because it's going to take the 10 minutes, but we talk about agents, and we talk about NeMo and the NeMo Toolkit and the NeMo Agent Toolkit, and how we can use that, how you can do this. So I showed this a little before. We have one of the demo scenarios here is basically the definition of an agent. And one of the ways that we can create an agent in the NeMo Toolkit is in a declarative way. Remember that we talked at the beginning that you have prompt agents, hosted agents, and more. So this is kind of a prompt agent. And this is an agent that's going to live locally in my machine. It's a YAML definition where I'm going to use NeMo LLM, and I'm going to use a Llama 321 model to do this. And it's going to have a workflow, which is going to be a child completion model, but it's going to be very simple with a simple prompt. This is the moment that, as Don mentioned before, you can use NeMo and declare this and connect this to your own data sources, your own system, enterprise systems, and more. But we have here one workflow that is basically a NeMo agent. Then I have also in C# using math, I have a bridge. And the bridge is literally a Microsoft Agent Framework application that is going to connect to the endpoint that is was created by the NeMo agent, and is going to expose the agent. Basically, we are using Agent Framework to connect and interact with the agent. And I have the third part here is a chat client that is going to connect to the Agent Framework to do this happen. So let's run this all together. And when we run this all together, it will look something like this. In the first top left corner, I am going to, let me copy this. I'm going to run the NeMo agent. So this is going to be the NeMo agent running. And remember, this is using the NeMo toolkit to create an agent, expose the agent. And by default, the agents have is compliance with the agent-to-agent specification. So I'm going to be able to use it and run it for everywhere. So after a couple of seconds, it takes some time. Did I press enter? I think yes. So after a couple of seconds, I am going to be able to access my agent. When I access my agent, not here, sorry, in the other one, it's live there. What I can do, I can go here to the NeMo agent, and I can access the card. This is a standard agent-to-agent card. So if I refresh this, this is my agent running locally, and I see that this is an agent powered by NeMo Agent Toolkit exposed at A2A protocol. Then, if I want to access my C# bridge, is not running yet. So what I need to do, I am going to access my bridge here. So when I run this, it's going to connect to the NeMo agent, and this is using Microsoft Agent Framework. And I have here running the bridge. And if I go here and refresh the health, there it is. It's doing the bridge and it's connected to the NeMo agent. So the third part here will be to run a chat client that I created that is basically going to talk with the bridge that we have here, and then the bridge is going to talk to the NeMo agent. So we can put it all together. So if I take a look at the NeMo URLs, this is it, the agent card for NeMo, the JSON endpoint, the bridge where we have here. And if I tap a custom question, like an example, hi, it's going to take some time. You can start to see how this is going to work in the back. The first time, as usual, because this is all local, it takes some time because it's going to load the model in memory, and it's going to make my GPU to work a little. But after a couple of seconds, I have, hey, I am a NeMo agent that basically assists to an incident. I need some information. So this is an agent that is only talking about incidents. So let me pick up one of the standard questions that we have here, a predefined question. I think this one is payment API return a 502 error code or something like this. So after a couple of seconds, the NeMo agent is going to give me the answer. And again, we are using this with Microsoft Agent Framework, which is kind of the nice part because we are putting all together here. And here the incident analysis is critical. Well, we have a problem category, and we also have a mitigation action and more. All of this running based on a very, very hello world simple definition of how the NeMo agent needs to work. But because it's an A2A agent, this is the moment that we can start to connect to literally everything. And I can host this here, I can host it in the cloud. I can do a lot of things. So we are getting to the end of the hour. Let me go back to the slides. And the final part that I want to share with you is that we've seen all of this running in Foundry. We've seen all of this running, taking advantage of DPU, the Neotron family, and more. But another piece that is very important, and again, go to build so you can take a look at this, is that each one of these pieces that we have in the Microsoft family, we all have now kind of a Foundry IQ, Fabric IQ, Work IQ, and more, and you can connect them all together. And this is kind of interfaces, smart interfaces that allows you to access this data. So if you have agents, like Don showed before, when you have 10 agents doing a rack, or 20, I can't remember, it was a big one, and you want to ask general question about all of that, you have Foundry IQ to basically give access to all of the knowledge that they are managing. And this is a super, super important piece that, again, at Build, you are going to see a lot of announcement around this, because now that we have tons of data, we have amazing enterprise support with Neotron, NeMo, and more. We have Foundry support in all of this. We can put all together and start to talk about this and start to do this and more. So that said, I think we are at the end of the presentation. Yes, we are basically wrapping up here. I am going to ask, if someone wants to test this, this is the only one that I will probably suggest everyone to test, which is go and take a look at the serverless GPU that you have right now. And again, you have GPUs in Azure Function, in Container Apps, and more. You can use your own code. You can deploy it based using the NeMo stuff that you have. And I will also try to see if we have some questions here in the last 5 minutes. And I also said, Don, did I miss something? Anything else that you want to add?
No, that was fantastic. You've covered the terrain quite well. I must say, at certain points, I couldn't. I'm like trying to read the code and follow what you're saying and trying to keep up. But there'll be a recording, so I can go over it again.
And yes, and we can go to YouTube. YouTube have this amazing AI where you can ask, summarize this, or what they say about this and that and more, and they give you that, which is also kind of nice. And
it was refreshing, let me say, to see it in C#, my favorite language.
I mean, I did a lot of machine learning in Python. I do a lot of machine learning also now in the mix. My 3 main languages are C#, C++, and Python. And for this, because we are, as I said, we are cooking stuff for build, I was moving the way of C#. That is what we are doing. But you can literally do the same if you want in Python or other languages. If someone is interested, I will be happy to also share the samples in other languages. And someone asked a question here that I don't know, and I don't know if you know, Don, but I will probably ask this for later. In one of your slides, you have CUVS, and is that CUDA vector storage or something else? I don't know. I think yes for the context, but we probably need to search about that. And as I said, it's all learning process. I will probably take that as a yes, but I don't know the final answer. And there was another one here.
The function in the blueprint was you need to have a vector database.
Yes.
So you get your chunks. Hopefully you get your chunks in an intelligent way rather than like every 500 words, get intelligent chunks. And then when you embed them, you'll end up with a vector. So you've got all of this information compressed in vector space. And so you need a vector database to put this into. You can use any vector database you want. But yeah, we felt like we needed to develop one, and our research department had all these ideas of how to like really do a vector database right. So they went wild.
Yes, and hey, a couple of people are saying excellent, both of you. Thanks, ability. We also have here gaming saying good session. More. I love one of the comments here because someone says that they want to have a couple of Sparks. I need to figure out a way to get a Spark at home, but it's a $5,000 device. 3,000. I can't remember. I know that when
I have a 4-Spark cluster.
Yeah, so I
right
remember
over
when
here that I'm gonna hook up after this. 4 Sparks. I went wild. Yeah.
Hey,
you can
here in Canada, you can probably
switch, and then you've got to get a switch with 200 gigabit ports on it. Those were backlogged, so I had to wait for that. Yeah.
Yes, because those have the crazy fast network switch. I don't know. It's completely out of my scope, but they are super, super fast. Yes.
Yeah, and each Spark has 128 gigabytes in it. So, 256, 512, now you can run some seriously large models. Yeah. Although Nano punches way above its weight. I should have probably brought like industry leading benchmarks and all of that sort of thing. But you'll see all that on our website.
Hey, I need to go back there. I need to. Someone also was joking about having to ask your manager. I need to find a scenario that my manager say yes, go for it, and have one at home. And in the winter, I will melt the snow with the Spark because I'm guessing that they get hot or more. Hey, we are at the top of the hour. We have a couple of people saying thanks, and thanks a lot for the tools and the feedback and more. And once again, Don, it was amazing. Thanks for everything. And seeing I have the last one saying thanks. I think we go back to Molly to wrap up everything. And hey, goodbye, everyone. Thanks a lot.
Thank you all for joining, and thanks again to our speakers. This session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. And we'll see you at the next one.